All right, so the next part of the lesson, we are going to use inverses of matrices to help us solve a matrix equation. So a matrix equation represents a system of equations. So again, this is just another method we're going to use to help us solve a system of equations. So again, when we're done, we're still finding that point of intersection. So this is just another method of doing that. So a matrix equation, we would have a matrix times a variable equal to another matrix. So this is just a very simple matrix equation. So whenever we solve an equation, to get the variable by itself, we always have to use the inverse. So for this problem, if we were actually trying to solve this, I have to multiply each side by the inverse of A. And we always want to multiply to the left side. So remember, order of multiplication for matrices matters. So again, by multiplying this part, this gives us our identity matrix, which is the same idea as 1. So we would be left with x equals the inverse of A times B. So we're going to take this idea and apply it to solving. So the first thing that we're going to do is we always set up our equation, and then we're going to find the inverse of A and take that times matrix B. Okay. So if this is our system, we are splitting it kind of into two parts. So we're going to cut it where there's the equal sign, and then we're going to write our two matrices, and you can actually skip over this step, but this is kind of how we're starting. And then we're taking away our variables. So when I'm looking at it, our coefficient matrix is going to have our coefficients with x and then our coefficients with y. This is our variable matrix, and then these are the constants. Okay. So again, we're going to take the inverse of this matrix times matrix B to solve our equation. Okay. So I'm going to start writing that. So we would have xy equal to, and then we have to find our inverse. I'll give a little space here because we don't know what that is yet, and then times 9 and 3. Okay. So that means we need to start by finding the inverse of A. So to do that, first thing we have to identify is the determinant. So we're going to start by finding the determinant of A. So we would take 1 times -6, so -6 minus 3 times 2, which is 6. So that is going to give us -12. Okay. So now for our fraction, it's going to be 1 over -12, and remember we always simplify the negative to the top. So this is going to be -1 over 12. And then in here, we are flipping the positions along that forward diagonal. So -6 and 1 switch positions, and then the signs change along the opposite diagonal. So -3 and -2. And now we are multiplying. Now remember, the associative property holds for matrices. So when I multiply, I'm going to multiply the two matrices together first, and then multiply the scalar in. So my -112 is still going to be on the outside. And then here we have a 2 by 2 and a 2 by 1 matrix. So again, our inside numbers match, and we're using the outside numbers. So we're going to have a 2 by 1 matrix to start with. Okay. So row times our column, so -6 times 9 is going to be -54. Plus -2 times 3, so -6. And then we would take our second row times our column, so -3 times 9 is -27, and 1 times 3 is 3. So now we're just simplifying. So -112 times -54 plus -6 is -60, and -27 plus 3 is -24. So now we're going to distribute that scalar in. So we would have -112 times -60. So we're really taking 60 divided by 12. So that's going to give us +5. And then again, -112 times -24. So we're really taking -24 divided by 12, which will be a +2. Okay. So again, this is what is equal to our x and y value. But again, remember, we're finding a coordinate. So we're going to write our final answer as an ordered pair. So the point of intersection is going to be 5, 2.